Hey everybody, welcome to the last lecture of electricity chapter. And before this lecture number 5, we have done the series parallel combination. We have also talked about the resistance, what is resistance, and on what all factors does it depend. Apart from that, we have also talked about the Kirchhoff laws, the another technique to solve the circuit diagrams if we are not able to solve them with the help of series and parallel combination. So, in short, till now the journey was around the solving of circuit diagrams. Yep. And apart from that, we had a discussion about the theoretical discussion about the resistance, on what all factors does it depend. And then also we had one class in which I discussed with you about the battery, that what is a function of battery and what exactly it does. So it does not provide the charge particle, actually it accelerates the charge particle. And now today we understand that in terms of the potential difference, that battery would always create the potential difference. That potential difference would accelerate the charge particle. And because of this, those charge particle will constitute a current inside the circuit. So that is what we have learned in the previous classes. So now what I'm going to discuss with you today is as follows. Yep. So in today's class, guys, what we're going to discuss is the heating effect of electric current and the electric power interrelation between P, V, I, and R. So this is one of the important topic for your board's exam point of view, as well as if somebody wants to go for Olympiads or such type of examinations in future like JEE and NEET. Because this topic is important, many times you'll be getting questions from here in a tricky way, as well as many questions are exactly related to our real life electricity bills and all these things which you see. All those things will be able to calculate with the help of this topic. So topic name is heating effect of electric current, and then later on we'll go electric power interrelation between power, voltage, current, and resistor. So these are the things which I'm going to discuss with you in today's class. Okay. So now let us begin first of all with the heating effect of electric current. All right. And just for your information, there are three total effects of electric current, which I guess you would have already studied in the grade 8 also. One is called the chemical effect of electric current. That was a complete new chapter for you guys. Then second thing is the heating effect of electric current, which I'm going to discuss with you today. And I'll be also telling you one law here. And then the third is the magnetic effect of electric current, which is our next chapter. So which is like usually we know by the name magnetism. So these are the three major effects of electric current. Like when electric current flows, it produces these three kinds of effect. So that's what we are going to discuss now. Okay, so I guess we have got the idea of what topic we are going to do now. So let us begin with the heating effect of electric current. Okay, so the story starts from here. Basically, we have seen that whenever the current flows, what is the reason behind it? If a current is flowing, the reason behind this is the battery. There is a battery, there is a resistor, and we have the connecting wires. So in those connecting wires, the charged particles are present. So whenever we connect that resistor with the help of a battery, with the help of those connecting wires, whose resistance we assume to be very small, with the help of those electric wires, those conducting wires, the charged particle would flow, right? And there is a battery, so they will keep flowing in the battery. Now, if these charged particles are flowing inside the battery, they would constitute an electric current. Now, what is needed for a charged particle to accelerate? So the thing which is needed is the potential difference, which we denote by the symbol V. So we know that whenever we apply the potential difference across any resistor, it would make the charged particle to go in a in a circuit diagram. Now, if this is the potential V, we are applying with the help of a battery. Suppose we have a battery here and I'm giving a voltage of 20 volt. So basically what does it? It tells you that if you have a Q amount of charge, then the energy which this battery would be providing to that Q amount of charge would be 20 Q. 20 multiplied Q. Why do I say that? Because we have defined potential at work done per unit charge. So total amount of work which this battery will be providing to the charge particle would be how much? It would be W by Q. All right. Sorry, Q into V. The work done would be Q into V. So basically, voltage of the battery is 20. That means if you have a Q amount of charge, then this battery would be providing Q into V. This much amount of work done, this much amount of energy to the system. System means those charged particles which are present over there. All right. Now the point is like this point, this thing we have discussed perfectly. That what is electric potential in the previous lecture, number 2, I guess. Yeah. So now potential is equal to W over Q. So if you are applying a battery, what this battery will do exactly? It will accelerate the charged particle. It will provide energy to those charged particles. But where is that energy going? That is the important thing. So you will say that, sir, that energy is going in providing the kinetic energy to the charged particle. Exactly, true. Because it is accelerating the charged particle, so it will provide the kinetic energy to them. That is wonderful. Now, if it is providing kinetic energy to them, what these charged particles will do with that kinetic energy? Now they will have to meet a resistor. So what they do, whatever energy they have got, they transfer that energy to the resistor. So now that's the job of resistor. It will oppose the motion of charged particle. So whatever kinetic energy they had, that energy will be supplied to the resistor basically. Okay. Now, if this energy is being supplied to the resistor, then what this energy with this energy, what does resistor do? So let us have a numerical touch also with that part. Okay, so I'm going to explain you the power. Energy is being supplied to the resistor, and who is supplying that energy? With the help of battery. All right, so battery is giving the energy to the charged particles, and the charged particles are giving energy to the resistor. Now, how much energy we are supplying per second? That is called power. So suppose if somebody is saying that I am supplying 20 joules of energy to a machine per second, that means my power is 20 watt. That's the unit of watt power. You can call it joule per second, or better way to write watt, WATT. Or if somebody says that a bulb is having wattage 100 watt, like normally we have seen those bulbs, 100 watt bulb, 40 watt, 60 watt, 30 watt, 400 watt heater. So what does it mean exactly? So this means that if 100 watt bulb is there, so it will consume 100 joules per second of energy. In 1 second, if you light the bulb, in 1 second it will be consuming 100 joules of energy. Right. So if you switch on the bulb for, let's say, 1 minute, that means 100 multiplied 60, 6,000 joules of energy it has taken. And depending upon that, like how much energy we consume, depending upon that, government will be charging the amount from you. All right. So that is why we always say that let us use a less watt bulb, because the less watt bulb will consume less energy. So it will require more, less electricity bill would be there. All right. Now, electric power. So electric power is nothing but energy supplied per unit time. Energy supplied, or we can say work done per unit time. So work done per unit time is the power. If that is the power, then what is the formula for work done? I mean, who is doing work? So battery is supplying the energy. So how much energy is battery supplying? Q multiplied its voltage. So QV divided by time. Now we know that Q upon T, charge per unit time, is nothing but what? It's called current. So I into V. So power is nothing but I into V. That's it. Power is nothing but I multiplied V. That's the final formula for the power. I hope you got my point. Now, after this, once we have understood what is power, it is I into V. Now we can say one thing, that we know that from the Ohm's law, P is equal to V is equal to IR. So I can also write it as I square R. All right. Or also, in the first equation, P is equal to IV, I can put I is equal to V by R again from the Ohm's law. So this will become P is equal to V squared by R. So now these are the three relations we have here. So this is known as the connection between power, voltage, current, and resistor. Okay. So energy and power are very close terms, but that does not mean that they are exactly same terms. Energy is not power. That's a very misconception. Power is basically how much energy we are getting in 1 second. That is called power. All right. So these are the two formulas: P is equal to I square R and P is equal to V square by R. I'm going to use these formulas in ongoing questions also. Very important formulas. And also we know that power is equal to V multiplied I. Now we can discuss one law here. So basically whatever energy we are supplying, that energy is being supplied to the resistor. That resistor can be anything. It can be a bulb, iron, toaster, stove, kettle, water heater. It can be anything. So now whatever energy we are supplying there, that energy will be going to that resistor, whatever load you have connected there, whatever appliance you have connected there, and it would generate a heat there. So now how much amount of heat is being generated? That calculation we'll do now with the help of that power formula. So this heating of the resistor, producing heat along the resistor, is known as the heating effect of electric current. Similarly, when a current flows, it can produce a magnetic field also. That will be known as the magnetic effect of electric current. If a current is flowing, it can carry out the chemical reactions. That will be known as the chemical effects of electric current. So right now my focus is on heating effect of electric current. That when current flows, it will produce the heat around the resistor. Okay. So now what is the amount of heat being generated? So power is equal to I square R. Any formula you can use, VI, V square by R, I square R. So if that is a formula for power, now power is means what? Power is basically energy supplied per unit time. Now where is this energy being used? This energy is being used along the resistor. So if this energy is being used along the resistor, that means that much amount of energy is being generated there. That much amount of heat is being generated there. So basically heat generated, which I will be denoting by the symbol Q, is equal to I square R multiplied T. Or you can say VIT, or you can say V square by R multiplied T. So now these are the formulas for heat generated across the resistor, along the resistor, whatever you say. Now one more thing, if this is known as HQ is equal to I square RT, VIT, or V square by R. There are those different forms. This is known as Joule's law of heating. Joule's law of heating. It's an important law. It can be asked in the exam just for 1 mark also, like what is Joule's law of heating, so you can explain in that way. So what you will have to write, that whenever the current flows through the resistance across the resistor, then it will produce the heat across it, and the amount of heat which is being developed is I square R multiplied T. So where T is the time. So let's say for 30 minutes the resistor is on, then that much amount of heat will be used. If 40 minutes is the time, then that much amount of energy will be used. So like that, we'll be using this formula. Okay. Now let us go ahead with the next part. What is the power of an electric appliance which is getting 220 volt potential difference and 5 ampere of current? So let us just see the question. So power they are asking, voltage is given, current is given. Very simple question. Power is equal to V multiplied I. So power is equal to 220 multiplied 5. That would give you 1100 voltage. So 1100 volt is the right answer. Simple question, just formula based. Okay. Now let's go to the next part. Now the next part is this type of question. This question I have taken from NCERT only. It's given as a solved example in NCERT. Let us understand the question. So basically, it's given that an electric refrigerator rated 400 watt operates 8 hours per day. What is the cost of energy to operate it for 30 days? at rupees 3 per kWh. I'll explain you what is per kWh. But before that, let us just find out how much energy it will be consuming. Forget about the this line. Forget about this line for now. I'll be using it later on. But for now, let us just calculate that we have an electric refrigerator which is being used 8 hours per day, and 400 watt is its power. I mean, is the energy required per second? What is the cost of energy required? That's the question. All right. Let us see. Okay. So, guys, see here. Basically, power is given as 400 watt. If we use this refrigerator for 1 second, it will be giving you 400 watts. It will be consuming 400 joules of energy. That's what the meaning of 400 watt is. If somebody is saying 400 watt refrigerator, what you should understand from it, ki when this refrigerator is on for 1 second, the power consumed will be 400 joules. All right. If we are using it for 8 hours, then total power will be 400 multiplied 8. So now this has become in hours. All right. So this was just, this is the kilo. Oh, sorry, this is the wattage, and this is hours. So basically, the final answer is 32 kilo. 3200 watt hours. This is the amount of energy which will be used. Are you getting my point? Basically, this was the power. Now, power is nothing but energy divided by time. So, guys, see one thing here. If you multiply power with time, what you will be getting? Energy only. So, this is what I have done here. 400 is the wattage, which is the power. I have multiplied this with the time for which it is being used. So 400 multiplied 8 is nothing but 3200 watt hours. So that's it. Finish. This is the amount of energy we'll be getting. That's the unit of energy, WH. Okay. Now, if you use it for 1 day, because that is 8 hours per day, if you use it for 30 days, now what would be the answer? For 30 days, this is the energy being consumed. I should say here total energy, not power. Total energy consumed by the refrigerator. So this is the energy consumed in 1 day. So for 30 days, guys, 3200 multiplied 30 watt hours. So this is the amount of total energy consumed for 30 days, for 1 month exactly. So 96,000 watt hours. I can write this as 96 kWh, because 1000 is nothing but kilo. That's the meaning. 10 to power 3 means kilo, 10 to power 2 means hectare, 10 to power 1 means deca, 10 to power 6 means mega, 10 to power 9 means giga, 10 to power 12 means tera. So basically, kilo means 1000, so 96 kilowatt hours. This is the amount of total power which is being energy which is being consumed by the refrigerator. Now, this kWh is called as unit. It's just called units. That is why you must have heard that whenever you get the electricity bill, we must have heard that the people are saying that this time we got 200 units of bill. This time we got 400 units of bill. This time we got 500 units of bill. So that's what the meaning of unit. So kWh is basically called the unit. So basically, what is the total units we have consumed? 96 units. So kWh is nothing but unit. That's it. One more thing. For per unit, the government is charging you. Now, in India, it depends upon the state. Suppose if you are in Bangalore, the cost is high there. If you come to Rajasthan, then again the cost is high. If you go to Delhi, then cost is very low, 5 rupees, 6 rupees per unit. If you come to, let's say, my place in Rajasthan, then the cost would be around 9 rupees to 10 rupees per unit. All right, so that is depending upon the government. It's depending upon the state government. They'll be charging you this amount. So wherever you guys are, there also the same system is being there, that you will be getting charged depending upon your units. So how many units do you consume? According to that, per unit they would be asking you for the money. If somebody has consumed 200 units, and if the amount is 5 rupees per unit, so he'll have to pay 200 multiplied 5,000 rupees. That much amount of electricity bill. If somebody is now, apart from that, there are, you must have seen that that is not the exactly electricity bill about. Right now I do not have an electricity bill, otherwise I could have shown you. There are some other charges also. Tax are there. Then apart from that, meter charge is there. The government is providing you the service, so for that they are taking the charge. And if you're using any transformer, that is not a case with the house domestic bills, but that is a case with the commercial bills. So in for a big coaching institute, like if you come to askIITians, or let's say if you go to a place where the energy consumption is very high, right? So in those cases we have to put our own transformer also. Okay, so for that we have to pay an extra amount. So it is like that. Actually the thing is like, so takeaway from the entire discussion is, we know how to calculate energy consumption, and depending upon that we can calculate kWh, right? And once we calculate that kWh, it is known as 1 unit. So 96 kWh means 96 units. That's it. And then you multiply with the amount. In this way anybody can calculate their electricity bill of the house, approximate. Okay, I'll try to give you one basic idea about it. Okay, so let us just have a look on this question in the end. At the rupees 3 per kWh. So for 30 days, total energy which we have consumed is 96. So for per unit, the charge is 3 rupees. So for 96 units, 3 multiplied 96. And that is how much? Is it 291 rupees? Just check my calculations. No, I think it's wrong. Yeah, it's 288 rupees. It's 288 rupees. So that would be the amount which we'll have to pay to government. So now let me take the same example, and I'll be discussing with you how you can how somebody can calculate the electricity bill of their own house. Okay, let us just have a look. I'll be giving you a very small idea, and the later part would be in homework for you guys. You guys can do that yourself. Suppose let me write here the appliance name. Then I will be writing here the wattage, and here I can write the number of hours we will be using them. Okay, and then later on, total watt hours means how much energy we have consumed, because watt and hours I'll be multiplying. I'll be getting the total watt hours, and then finally we'll have to convert this into kWh also. Just a second. Or in the end also we can do that, no problem. Yeah, in the end we can do that, no issues. Let me just write here watt hours. Okay, basically that's the units. Sorry, watt hours. Okay, so total energy which we have consumed. Okay, so guys, see, appliance, let us take first of all the TV. TVS. Now usually the TV, I don't remember exactly, let's say 50 watt. So 50 watt is, and we are using the TV for, let's say, 6 hours. So 300 watt hours. That is the amount of energy we have consumed per day. Okay. Then later on, let's say somebody uses bulbs, and each bulb is of, let's say, 40 watt, and we are using it for 8 hours in a day. So there are, for one bulb, 40 watt. 8 hours means 320. 40 multiplied 8 is 320. But we have 3 bulbs here in the house. So 3 bulbs means everything will get multiplied with 3. So 3 multiplied 320, which would give you 960 watt hours. Let's say we are using 2 fan. Okay. So let's say 80 watt and 2 fan we are using for, let's say, each fan I'm saying. In the previous case when I said 3 bulbs, so each bulb we were using for 8 hours. So in total for all 3 bulbs 24 hours. Now 2 fan, again the same amount of time, around 10 hours we can take. Yes. Okay, so 10 multiplied 2, 10 hours we can take here. So 80 multiplied 10, 800 for one bulb, for one fan. For 2 fan it would be 1600 watt hours. Then apart from that, just now we took refrigerator, that also we can calculate here. Now for refrigerator, let's say it's of 400 wattage and we are using 8 hours per day. So one refrigerator is there, so 3200 wattage. All right. Then apart from that, what else? Wi-Fi. Wi-Fi is very low. Let's say 10 wattage only, very small. So Wi-Fi is 24 hours. All right. So 240 wattage for Wi-Fi. That will also connected to a power circuit. And what else we can take? Some basic parts we have taken. Okay. Now apart from that, air condition, then if somebody is using cooler or tube lights, whatever you guys are using, you can write that here and you can calculate your electricity bill. In the end, let us calculate this entire thing. Let us do the summation of this. So 300 plus 900, 1200. 1200 plus 1600, 2800. 2800 plus 3200, 6000. 6000 plus 200, 6200. 6200 plus 60 plus 40, we left there 6300. Just check the calculations if I made any mistake. So 6300 watt hours of unit we have consumed in a day. All right. Now to convert this into kilowatt hour, what I'll be doing, see here, 6300 watt hours. So I want to convert this into kilo. So let us just do one thing. Multiply with 1000 and divide with 1000. This is the very basic method I'm teaching you. Otherwise, if you are if you are comfortable in just dividing with 1000, that's pretty good. But 6300 wattage. So I'm going to multiply with 1000 and divide with 1000. Why I'm doing this? Because I want to convert this watt hours into kilowatt hours. Now I can say this is nothing but kilowatt hour. So 3 zeros are there. So this will become 6.3 kilowatt hour. 6.3 kilowatt hour. So that is a total amount of energy which is being consumed by this user. This user, 6.3 kilowatt hours. Okay. And let's say he's in Rajasthan. So this is called unit. So 6.3 units he's getting per day. Now for 30 days, for 1 month, 6.3 multiplied 30, 189 units. I guess I'm correct. Let's check it. Yes, it's correct only. So 189 units that person is using who is having this much energy consumption. And let's say for per unit, the charge is 10 rupees. So 189 multiplied 10, 1890 rupees. That is the electricity bill for his house. Now you must also calculate, depending upon your state or depending upon your country, how much charge you guys are paying there. So this way you can calculate the approximate bills. Okay. So that is the Basic idea I have told you how we can calculate the electricity bill. Okay. Now let us go ahead with the next type of question which can be asked. So one possibility is that CBSE can ask you such type of questions depending upon how to calculate electricity bills and all. Now second possibility also let us discuss. Now one before I go for the second question, I would like to discuss with you one basic example about the electric bulb. We all have seen about the electric bulb, that is regarding the wattage. So we have seen that, let's say we go to market and we purchase a bulb, and that bulb is of 100 wattage. So what is basically written on that bulb? It's a very important topic. So pay attention here. If you don't understand, then I would recommend you to watch it once again. But it should be clear to everyone. Okay. Because it is directly connected with our day-to-day life. Okay. So let's say we go to market and we purchase this bulb, and this bulb, on the bulb you would find a rating 100 watt, comma 220 volt. So what does it mean? 100 watt is 220 volt. What does it refer to? What does it tells you that when somebody says 100 watt 220 volt, what does it mean? This means that this bulb would provide you 100 joules per second of energy, correct? If 220 volt of energy is being supplied to it, I mean voltage is supplied to it. So from outside, from power station, we are getting 220 volt only. Okay. And if our bulb is getting 220 volt of energy, right? 220 volt of potential difference across it, then it would give you 100 joules per second of energy. But if our bulb is not getting 220 volt, if it is getting, let's say, 110 volt, now what would be its power? Will it be same again 100 voltage? No, because now it is getting less voltage. So now the question is, suppose now if this bulb we brought from the market, and that was a rating from market, when we brought it, this was a rating, but they have written that when you will provide 220 volt, then I'll give you 100 voltage. If you don't provide me, if you won't provide me 220 volt, I won't give you 100 voltage. I'll give you less than that. Okay. So now if the same bulb is being used with the 110 volt of battery, now what would be its power? That's the question. It can be asked in the exam. It can be asked. So now what would be its voltage? That is the question. Let us discuss just now here. So guys, always remember for such type of questions that whatever is the rating, whatever is the voltage, the one thing of the bulb will remain same, and that is its resistance. So whatever resistance it had in the beginning, that will be same as the final resistance. So if somebody is using 100 volt bulb with 220 volt potential difference, so power is equal to V square by R. So R is equal to V square by P. So 220 squared by 100. This is the resistance. So final resistance R2 will be V square, which is 110 whole square, divided by power is P. Now this thing R1 and R2 must be same, because resistance change nahi hoga. Resistance would be exactly same. Right? Resistance is a property of that filament which is there inside the bulb. Okay. So that's why resistance is not going to change. Now, if resistance is same, so initially the power was 100 watt. Now the power would be some P, because the voltage we have supplied is 110. So R1 equals to R2. So 220 whole square divide by 100 is equal to 110 whole square divide by p. So usually like whenever we see such type of questions that 100-watt bulb is there, 220 is being the voltage. Now if we supply the voltage 110, what would be its power? So we get the answer 50 watt, and that option would also be there. But do not go this way. Uh, we have to think properly. Now, so that is the main part here, 220 square. Okay, so let us just cancel it out. So 110, this will get cancelled out 2 times. So square is there. So power is equal to 25 watts. So power will become 1/4 because power is V square by R. So power is, if voltage is becoming half, so power will become 1/4. That's a good question. So always keep this thing in the mind. How to solve this question. One more question I can take. Now I hope you understood what does the meaning of rating. Okay. But actually the brightness of the bulb would depend on its voltage which it is getting. So now sometimes the question we get from the brightness. So power produced or heat energy produced by the bulb decides the brightness. So more is the energy produced per second, more would be its brightness. Let me take one question. Suppose I take 3 bulbs. I have connected them with the 220-volt battery. It can be 100-volt also, anything. I'm just taking 220-volt. Let's say the bulb 1 has a rating 100 watts, second one has a rating 80 watts, and third one has a rating 40 watts. Okay, you know exactly what is the meaning of this rating. 100 volt it will supply when you will provide 220-volt energy, potential difference. Okay, now I have connected all three with a single 220-volt battery. That was just the marking on the bulb. 100-volt 220-volt, 180-volt 220-volt, 40-volt 220-volt. But now actually what I'm supplying is 220-volt. So we have to compare the brightness of the bulb. Very simple. Power directly proportional to brightness. Now power formula is V square by R. It can be I square R also. But I'll be using V square by R. The reason is very simple. Here in this case, if you see, then every bulb would be getting the same power. Oh, sorry, same voltage because they are in parallel connection. This is 220-volt parallel. This is 220-volt and this is 220-volt. So every bulb is getting 220-volt. And now at 220-volt, the bulb 1 has the greatest power. So its brightness would be more. Bulb 2 would have the little bit lesser, and bulb 3 would have even more lesser. So that is the relation. So bulb 1 would have the more glow, 2 would have even lesser, third would have even more lesser. Okay. Now let us take the same question, but this time in a series combination. 100 volt is again 220-volt. 80-volt is again 220-volt. And 40-volt is again 220-volt. But now they are connected to 220-volt battery in series combination. Now what will happen? Power is equal to V square by R. But in this case, the resistance of every bulb would be different because their rating is done for 220 volt. Every bulb would have the different resistance. Every bulb would have the different power. Every bulb would be getting different voltages because in series combination current is same, not the voltage. So voltage drop across each resistor would be different. Okay. But one thing which will remain same, though, like if every bulb would have got separately 220, they would have given you 100 voltage, 80 voltage, 40 voltage. But now we know that this 220 volt which we are providing, that will be divided among this one, and among this one. 1, 2, 3. So what will remain same is the resistance. Now when this power is being supplied, when this energy is being supplied to 220 by the 220 volt battery, we will be using this formula to compare the brightness, I square R. The reason being because current would be same from everywhere, from each bulb. Same current I would flow. So power is directly proportional to the resistance here in this case. If resistance is more, power would be more. So let us just calculate the resistance. So for first one, V square by P. So when 220 you supply, its power is 100. For second one, it's in ohm. 220 square divided by 80. 220 square divided by 40. Now which bulb would have the more resistance? Of course the bulb number 3. Then bulb number 2. And bulb number 1 would have the least resistance. So bulb number 3 will have the more glow, then 2, and then 1. So how amazing is this? 220 volt battery and 3 bulbs of different voltages. But the point is, every bulb is getting the bulb 1 would have the more brightness if it is connected in parallel. The bulb 3 would have the more brightness, which was having the less voltage, 40 volt, if they're connected in series combination. So that is the very beautiful part behind the electricity. Okay. So that was the end of the chapter. And that's how we solve the questions of series parallel combinations and the voltage formula and how do we calculate electricity bills. Everything we have discussed in today's class. I hope all the points are clear to you. If any confusion, any question you would have, just tell me. I'll be available for you. And if you have any question, just put it on the PDF apart from that. So thank you so much, guys. Enjoy and stay safe.